Hi, my name is Norma Becerril and I'm going to present the influence of the temperature on the fast transformation of titanium zirconium tungsten directed to biofuels production. Mixed oxide catalyst has been used in the transformation of the molecules of biomass, turning them into molecules with high added value. Biofuels have similar properties to fuels obtained from the non-renewable sources. Second-generation biofuels are those obtained from forest residues through dehydration and hydrogenation reactions. Titanium zirconium oxide are important because of their acidic properties and high surface area. In this work, two series of materials were synthesized using soil and sonochemical methods, varying 1, 3, 5, and 10 their weight percentage of tungsten concentration. The effect of heat treatment temperature of 500, 650 degrees, 700 degrees, and 80 degrees, 800 degrees in the transformation phase of titanium zirconium tungsten oxide was also studied. The titanium zirconium tungsten catalysts were synthesized via Sol-Hell method with 1 molar ratio of titanium zirconium. The amount of necessary salts was added depending on the balance carried out for the molar ratio between the divalent using two solutions. A solution with the necessary amount of acetic acid and distilled water maintaining a constant pH of 3 was prepared, and another solution prepared with the mixture of titanium butoxide, zirconium butoxide, and 1 butanol a solvent with the necessary amount metatungstate at different tungsten concentration such as 1, 3, 5, and 10 weight percentage. Then, both solutions were mixed maintaining an alcohol-water molar ratio of 1:16. A system at room temperature with constant stirring of 800 revolutions per minute was established, and then the drip of water solution at pH 3 prepared was adjusted for automatic dosing during 2 hours. Subsequently, stirring was continuous for 24 hours to achieve aging, and the first drying was carried out until the presence of water and alcohol was eliminated in an oven at 80 degrees during 48 hours. A second drying was carried out. The material was annealed at 500 degrees in a tubular furnace under an 8 atmosphere for 12 hours with a heating ramp of 2 degrees per minute in order to eliminate organic and inorganic impurities from the material. Then the materials were annealed at 650, 700, and 800 degrees respectively in order to study the fast transformation. Finally, the sonochemical method was followed with the same synthesis procedure, aiding the exposition to the cavitation in a Branson 8890 ultrasonic bath with a frequency of 40 kHz. The catalysts were characterized by X-ray diffraction, nitrogen fission, carbon dioxide, programmed ammonium temperature desertion, and scanning electron microscopy. From X-ray diffraction, it was found that for both series annealed at 500 degrees, the X-ray diffraction are characterized by amorphous materials with an induced phase near 30 to theta degrees corresponding to the 1-1 plane. After raising the annealing temperature, it was observed that the crystallization began at 550 degrees. When the temperature was increased until 800 degrees, the appearance of Sri Lankan was observed, the same such as a tungsten trioxide segregate phase. Another effect detected was that when the tungsten content is increased, the stability improves and the presence of tungsten trioxide is associated with the formation of tungsten oxide zirconium bonds on the surface of the material, which reduce the mobility of the zirconium atoms on the surface, preventing sintering. On the other hand, physics-torsion analysis exhibit mesoporous materials with isotherm type 4 and hysteresis loop and surface areas with values between 226 to 243 square meters per gram for Sol-Hell and from 255 to 212 square meters per gram for the sonochemical method. The volume pore distribution exhibit an unimodal behavior in both methods. The Sol-Hell method owns higher pore distribution values with a maximum of 0.31 cubic centimeters per meter on 5% tungsten content and a minimum of 0.28 cubic centimeters per per gram on 10% tungsten, while the sonochemical method exhibit lower pore distribution values with a maximum of 0.21 cubic centimeters per gram on tungsten and a minimum of 0.12 cubic centimeters per gram on tungsten. At last, it was detected that the pore diameter for the sonochemical method is more uniform for soil-held materials. Besides, the quantification of the basic and acid sites was carried out by carbon dioxide on a programmed ammonium temperature distortion. Carbon dioxide TPD shows that the energy are higher for the soil-held samples with a greater strength with very weak basic sites observed on the sample without tungsten. On the other hand, the ammonium TPD results evidence that the surface ammonium interaction energy and the amount of acid site associated to the weak acid site is higher in the catalyst synthesized by soil-held method without tungsten, and once the tungsten is added, the material synthesized by sonochemistry shows higher basicity and higher acidity. SEM analysis demonstrate that the sample synthesized by soil-held and anneal at 800 degrees shows an average particle diameter greater than the one synthesized by sonochemistry. For example, titanium zirconium tungsten with 5% of soil-held was 2099 micrometers against titanium zirconium tungsten with 5% of sonochemistry was 161 micrometers. As expected, the samples obtained by sonochemistry show less agglomeration than those obtained via soil-held. And finally, it was found that through sonochemistry, it's possible to reduce the synthesis time from 80 hours by soil-held to 18 hours by sonochemistry. In addition, the characterization results show that the materials obtained via sonochemistry preserve the best characteristics, making them ideal for carrying out the production of biofuels. At 500 degrees, all the samples synthesized by soil-held and sonochemistry showed amorphicity, while the crystallization began at 650 degrees, increasing the annealing temperature to 800 degrees. The Sri Lankan and tungsten trioxide aggregate phases are observed. The nitrogen fission analysis for annealed samples of 500 degrees reveals mesoporous materials with a type 4 isotherm, and the carbon dioxide analysis, TPD analysis, demonstrate that the type of basic sites are very weak for both methods. On the other hand, the ammonium TPD analysis indicates that the acid sites correspond to weak sites. Finally, we would like to express our gratitude to CONACYT for the doctoral scholarship at the Universidad Juárez Autónoma de Tabasco and to Dr. Mayra Alvarez Lemus for the fission analysis. Thank you very much.